So this is Gayatri Priya, Assistant Professor in the Department of EC of RMD Engineering College. In today's session, we are just going to discuss about the basic concepts of Wallace tree multiplier. Right. So what is a Wallace tree multiplier and how it going to be operate? Okay. So that is the thing we are going to discuss in today's session. Right. So this Wallace tree multiplier is the fastest multiplier. Why it is called the fastest multiplier in the sense it is going to implement the full adders as the carry save adder. So already we have learnt about this carry save adder which is capable to reduce the computational as well as the propagational delay time. Right? Okay. Now let us take an adder, a full adder circuit whose input is going to be A, B and Ci. The output are going to be S and C0. Right? Here we have written the truth table of this full adder. So usually we will be writing what is the input A, B, C, I and we will be mentioning what is the output, that is sum and the carry output. Here we have included a one more column which just counts the number of ones present in the input. Right? So in this first data 000 there is no ones, therefore we have put it as 0. So for the next data 001 the number of ones is going to be 1. So whereas if I take 011 the number of ones is going to be 2. Right? So like that we have listed down how many number of ones present in the input. In the last data 111 we are having 3 numbers of ones. Okay. So there is a relationship between this number of ones as well as this sum output. Right? You could see when the number of 1 is 0 or whenever it is going to be an even number, we could see the sum is 0. Okay. So here it is 0, here it is 0, 0, 0. So whenever we are getting the number of ones as 1, so what happens? The sum will be 1 and the carry output remains as 0. Whereas if I am having the input as 111, that is I am having 3 numbers of ones, here we could see both the sum and the carry output are ones. So in simple we can say if the number of ones is going to be 0 or in even numbers, the sum output is 0. If it is going to be an odd number, we will be getting the sum output as 1. So with this logic, we can just form a 3:2 compressor. At the same time, a 4:3, 5:3, 6:3, 7:3, 8:4, 9:4 compressor. Depending upon the number of input and how we are getting the sum output, we can make use of any number of compressor. For example, if you are going to give n number of input, we will be getting log n number of output. Yeah, so this is a simple representation for the execution of the multiplier. Right? So here we could see 2 power 0, 2 power 1, 2 power 2 and 2 power 3. So this is nothing but a 7:3 compressor is being used. So and here we are having W3. W3 is nothing but it is going to act as a 3:2 compressor. So all the full adders operations are being performed, all the carries are being received and finally at the carry propagate adder we are going to add the entire number of carries. So only in this stage we will be having a little bit of propagation delay. That is because of the transition of the ripple content from the LSB towards the MSB. So in these stages and all we don't have any such delays. So by this way we can reduce the complexity as well as the propagation delay so that we can have a fastest multiplication operation by making use of this Wallace tree multiplier. Right? Here if you could see this W7, okay, here we have given 7 inputs, okay, and the outputs are going to be 2 power 0 which is extracted directly and 2 power 1, 2 power 2. 2 power 1 is given to the carry propagate adder, whereas 2 power 2 is again passed on to a 3:2 multiplexer. Similarly, from this W7 you are getting 3 different inputs, 2 power 1, 2 power 2 and 2 power 3. 2 power 1 is given to the previous stage, 2 power 2 is given to the next 3:2 compressor and 2 power 3 is given to the next stage of 3:2 compressor. Likewise, this process is repeated until we get the finalized output through the carry propagate adder. It is capable to add right from 2 power 0 to 2 power 7. all the 8 number of carries are being added and it is processed through the carry propagate adder, right? So in this W7 and W3 are going to be the carry save adder. All the carries are then added by the classical full adder, or we can make use of the carry propagate adders. So the delay is only in this carry propagate adder. So the remaining times are being saved, and hence this Wallace tree multiplier would be referred as the fastest multiplier. Hope you understand these sessions. Thank you.